Next topic we're going to discuss is inverses of linear functions. Now, as definition states right above, an inverse relation is basically just a set of ordered pairs obtained by switching or exchanging the x and the y coordinates. So you'll see over here I have a relation which is defined as a set of ordered pairs or x and y values. And if we want the inverse of this relation, all I need to do is switch each x and y. So the inverse is going to be made up of the point 3, 1, 7, negative 2, and negative 12, 4. And this is the inverse relation. So now if I apply that to a couple of graphs, and I want to graph the inverse of these relations, remember, all these pieces of this graph are just points made up of x's and y's. So this is the point 0, 1. Here I have the point 2, 4. And this looks like the point 4, 2, 4, 7. So now if I want to graph the inverse of this, all I have to do is switch all the x's and y's. So I'm going to graph, instead of 0, 1, 1, 0. Here's that point. If I want to find the inverse of 2, 4, I graph 4, 2. If I want to take and graph the inverse of 4, 7, I go out to 7 and up 4. Plot those 3 points, connect the dots, like so. Continue the line, and the green line is the graph of the inverse. Likewise, over here, I'll find a couple of points. One point is 3, 0. Whoops. 3, 0. The other point I have is negative 2 and 5. And if I want to graph the inverse, once again, I switch the x and the y coordinates. So instead of 3, 0, I have 0, 3. I graph that point. And instead of negative 2, 5, I have 5 over and negative 2 down, which is somewhere around here. And we'll notice this is kind of an odd situation. The inverse appears to be very close, if not the same as the line itself. So this is kind of a unique inverse. But again, it's just a matter of switching the x and the y values. So now let's apply this to actual functions or equations. So if we have a linear relation, we say it can be described by a function that generates the set of points. And remember our function notation of f of x. And we call the inverse function as this notation right here, where we have f of, looks like raised to the negative 1 power, but that basically says the inverse of x. And in order to find the inverse of a function, basically what we're going to want to do is we're going to replace the f of x with a y. So in this problem here, I say y equals 7x plus 10. And like we did with our points, the next thing we're going to do is we're going to switch our x and our y's. So I make this x equals 7y plus 10. Then we're going to solve for y. So if I want to solve for y, subtract 10 to both sides. Get x minus 10 equals 7y. And then I want to solve for y, so I'm going to divide by 7 to each term. And I get 1/7 x minus 10/7 is equal to y. And finally, we're going to replace the y value with the inverse. So the inverse of the function of x is equal to 1/7 x minus 10 over 7. And we can do the same for problems that look like fractions. Again, this is in slope-intercept form, so I'm going to replace the f of x with a y. I'm going to switch the x and the y. and I'm going to solve for y. So in order to do that, I add 3 to both sides. I get x plus 3 is equal to negative 4/5 y. Multiply by the reciprocal to both sides. We want to multiply both sides by 5/4 of the negative type, and I get y equals negative 5/4 x minus 15/4. Replace the y with the inverse notation, and we get negative 5/4 x minus 15/4 is equal to the inverse. So what I'd like you to do is write a lesson summary, answer the following questions. We have the first two here, and then we'll have a third problem right here, which is a multiple choice. We'll see you tomorrow.